Right, section 7.4 is on solving word problems involving quadratic equations. And basically, when you're solving any kind of word problem, you always got to remember to check your answer to make sure it makes sense in the context of the problem. Most of the quadratic equations we solve, we end up getting two answers, and sometimes one of those answers doesn't really make sense in the context of the problem. For example, if your equation is about area, and you end up x representing like the width or the length, and you end up with a negative value for x, then in the context of that problem, the negative would be an inadmissible root because you can't have a negative length. So you must reject those solutions that aren't don't make sense with respect to the problem. So some of the words you should be familiar with would be product means multiplication, sum means addition, two more would be like add to, two times would be to multiply by two, and so on. So when you're given a situation, you may or may not be given the equation. If the equation is given, you just need to interpret the words in the problem to figure out what you need to do. And usually you're given enough information to substitute for one of the variables in the equation. So you basically substitute for the appropriate variable and then solve the resulting equation. And usually it involves bringing all terms to one side equal to 0, and then either factoring or quadratic formula would be your preferred methods to solve. If the equation is not provided, you need to look at the information and assign a variable to the thing you're trying to find, and then come up with an equation that relates the variable that you're trying to find to information in the problem. And then solve of course, that quadratic equation, and remembering to reject any answers that would be considered inadmissible. Okay, so the first example there is the height h meters of a toy rocket above the ground at time t seconds after the launch is given by quadratic function h of t equals negative 4.9 t squared plus 14t plus 2. So the first question asks you what's the initial height. So when they say the initial height, that means at the beginning. So time would be 0. So you would be just solving for the t value equaling 0. So 4.9 times 0 squared plus 14 times 0 plus 2 is going to give you 0 plus 0 plus 2, or 2 meters is the initial height. What is the maximum height? So when you see the word maximum, you've got to think vertex. So the vertex would be, in this case, it would be a parabola that opens down. So it would have a vertex. The x-coordinate in our word problem has t for time, and the y is a height. So if we want to find the time at which it's reached, it's like finding the x-coordinate of the vertex, which we can find using negative b over 2a. So the negative b would be negative 14 over 2 times negative 4.9 is the a value. So that would be negative 14 over negative 9.8, which we're going to approximate to about 1.4 seconds. So that's the time at which the maximum is reached, and the maximum would be the height at 1.4 seconds, which would be negative 4.9 times 1.4 squared plus 14 times 1.4 plus 2. And that will give you negative 9.604 here plus 19.6 plus 2, which will give you it's 11.996, or approximately 12 meters, yes. So 12 meters at 1.4 seconds. And what is the the height of the rocket 2 seconds after the launch? Well, what they're giving you is a time. So you just want to find the height at 2 seconds. So that would be negative 4.9 times 2 squared plus 14 times 2 plus 2. which is going to be negative 4.9 times 4, so that's going to be negative 19.6 plus 28 plus 2 which is 10.4 meters at 2 seconds. And the last question, it's algebraically determine the time it takes for the toy rocket to hit the ground. Well, that there you'd have to interpret. To hit the ground would mean the height would be 0 meters. So you'd be solving 0 for the height equals negative 4.9 t squared plus 14t plus 2. So I wouldn't want to factor that, so I'm going to go right to quadratic formula. It's already set up to do quadratic formula, so t would equal negative b in this case would be negative 14 plus or minus the square root. B squared is 196, I think, yep, 14 squared is 196, minus 4a is negative 4.9, and c is 2 all over 2a is 2 times negative 4.9, which I know is negative 9.8. So that's going to be negative 14 plus or minus. You're going to get 196, and that's going to be 2 negatives are going to make that a plus. Four times 4.9 times 2 is 39.2. All over negative 9.8. So that would equal negative 14 plus or minus the square root of 196 plus 39.2 is 235.2 over negative 9.8. If I come over here now, that would give you negative 14 plus or minus the square root of that. Second square root of 235.2 is 15.34, around there, all over negative 9.8. So that gives you t equals negative 14 plus 15.34 over negative 9.8, which is approximately negative 0.14, and this would be seconds, or t is negative 14 minus 15.34 over negative 9.8, which would be negative 14 minus 15.34 divided by negative 9.8, which is approximately 2.993, so it's approximately 3 seconds. So when we look back at our answers, our t's are supposed to be times, so this one here doesn't really make sense. So it would take 3 seconds for the rocket to hit the ground. Okay, the next problem says a rectangular lawn measuring 8 by 4, so sometimes it helps to draw a diagram. So this would be 8 meters by 4 meters, and surrounded by a flower bed of uniform width. So that's basically, you're going to have a diagram, another border going around the edge. And when it says uniform width, that means this width here is the same as this width here all the way around. So it gives you the combined area of the lawn and the flower bed is 165. So that would mean the total area of the outside rectangle, basically. So we'd want to find the dimensions, something to represent the dimensions of the outside rectangle, which would be, if this is 8, and I'm adding this little piece on and this little piece on the end, the whole length of that outside piece would be 8 plus 2 times whatever x is. And similarly, the width would be 4 plus an x on this end and an x on that end to give you a width of 4 plus 2x. So your area is length times width, and we know that the area is 165, and we know that the length is 8 plus 2x, and the width is 4 plus 2x. So there's our equation. All we have to do now is simplify it and solve it. So 8 times 4 is 165, sorry, is 32 plus 16x plus 8x plus 4x squared. And then we want to bring, it's a quadratic equation, so we want to bring everything to one side equal to 0. So this is going to be 32 plus these two can come together and give you 24x plus 4x squared, and then I'm going to bring that 165 over, so it's minus 165. So that would be 4x squared plus 24x minus 132, 133 is it? Check that. Sometimes I make stupid mistakes when I'm... So that would be one. I wouldn't want to factor that, so I'd just go straight to the quadratic formula. X equals negative b plus or minus the square root of b squared, which is 576, minus 4a is 4 times c is negative 133, all over 2a, which is 8, and that's going to be negative 24 plus or minus the square root 576, and two negatives there are going to multiply by each other and give you a positive. 4 times 4 times 133, which is 2128 over 8, which is going to equal, just going to bring that up here so I have a little bit more room. So that's going to equal negative 24 plus or minus 2704 all over 8, which is going to be negative 24 plus or minus 52. That works out to be a nice perfect square. So that gives you negative 24 plus 52 over 8, which is going to be 3.5 meters, or negative 24 minus 52 over 8, which is going to be a negative, so we're going to reject that. So 3.5 meters seems to be the value for x that we have. So the width, and that's what you're asked to find, the width of the flower bed. Okay, our next problem says a right triangle has side lengths of x, 2x plus 4 and 3x minus 4 is shown below. What is the measure of each side? So when you have a right triangle, you can use Pythagorean theorem to relate the sides. So Pythagorean theorem states, if you can't remember, that leg squared plus the other leg squared, and the legs are the ones that make up the right angle, equals the hypotenuse squared, or the sides that make up the right angle. So one leg is x in this triangle, and the other leg that makes up the right angle is 2x plus 4. So if you square each of those and add them together, you should get the hypotenuse, which is 3x minus 4, all squared. So there's your equation that you can use to solve for x. So all we have to do now is simplify that. So this is going to be x squared plus 2x plus 4 by 2x plus 4 equals 3x minus 4 by 3x minus 4, which is going to give you x squared plus 4x squared plus 8x plus 8x plus 16 equals 9x squared minus 12x minus 12x plus 16 when I multiply that out. So that would give me 5x squared plus 16x plus 16 equals, I'm just putting the like terms together there, 9x squared minus 24x plus 16. So I'm going to bring everything to one side so that the other side is 0, and I'm going to bring it all to the right side because I like having positive x squareds in my equation if I can, so there's more x squareds over on the right side. So that would be 9x squared minus the 24x plus the 16, and then I'm going to subtract the 5x squared, subtract the 16x, subtract the 16 from the other side. So that's going to give me 9x squared minus 5x squared is 4x squared. Negative 24 minus 16 is going to give you minus 40x. And then this one's nice because the 16s actually cancel. So this one is a real easy one to solve because you can just factor out the GCF. I don't need to use quadratic formula here. I can just factor out the GCF of 4x and get 4x outside of x minus 10, which gives me two solutions for x. Either x is 0 or x is 10. And we would reject, in this case, x equals 0 because if x is 0 you wouldn't have a side length. So x must be 10. And if x is 10, then 2 times 10 plus 4 is going to be 24. And then 3 times 10 minus 4 is going to be 30, take away 4, which is 26. So you have, there's the three sides, 10, 24, and 26. So 10, 24, and 26. Okay, this problem we're going to omit that. We decided not to do the the revenue, type problems. Okay, so this is another common type of problem, and the one we talked about, the border width problems, are very common problems for tests and assignments and exams. So it said the flower bed is in the shape of a rectangle, its length is twice its width, and the bed is surrounded by a 4-meter wide walkway. So if the total area of the bed and walkway is 504 meters squared, algebraically determine the width of the flower bed. So that's what we're going to let x be, the width of the flower bed. Okay, so we fill in what we know here. We don't know the length or the width, but we do know the length is twice its width. So if I let W be the width, then this should be 2W on the length. The bed is surrounded by a 4-meter wide walkway, so we know that this walkway is 4. And no matter where I take the width of that walkway, it would be 4. So the total area of the bed and the walkway is 504 meters squared. So that means that we need to, if you're talking about the total area, we want the outside dimensions of that rectangle. So this dimension here would be W as far as here, this little bit, but then you got a 4 added on this end and a 4 added on that end. So it'll be W plus 2 4s or 8. And this one here, again from here to here would be the 2W, so that amount would be there 2W, but then you got a 4 on this end and a 4 on that end. So it'll be 2W plus 8. So our area is length times width, which means our area we were given is 504, our length is 2W plus 8, and our width is W plus 8. So if we expand that now, we get 2W squared plus 16W plus 8W plus 64. And then we just simplify that. And then we bring everything to one side so that the equation equals 0. And then we can solve using factoring or quadratic formula. So this is going to be 2w squared plus 24w minus 444, is it? Or too tired to add that in my head there now. 440, yeah. So minus 440. Now one thing you can do when you're solving is you can divide both sides by a constant. Only do this when you're solving. By constant to make the numbers a little smaller to work with in your quadratic formula. So you can only do that when you're solving. And divide both sides by 2, and that gives you 0 equals w squared plus 12w minus 220. Now you can use quadratic formula here to solve this, but I like factoring, and I can see what the factors. This is an easy one to factor for me, because I know that this times this is going to give you w squared, and two numbers that multiply to give you negative 220 and add to give you 12 will be positive 22 and minus 10. So that gives you solutions of w equals negative 22, which I can reject here because a negative doesn't make sense for the width, and w is 10. So this would be and it would be in meters. So this would be the width of the flower bed, which is what I'm looking for. So that would be my answer. Now, if you don't like to factor, you can use quadratic formula there, and you will still get the same answers. And the last question is: a square and a rectangle have the same width x. The rectangle's length is 1 centimeter more than twice the width. So when the area of the square is subtracted from the area of the rectangle, the result is 56. Determine the width of the square and the rectangle. So if we have a square and we have a rectangle, and we know they both have the same width x, but it says the rectangle's length is 1 centimeter more than twice the width, so that would be 2x plus 1. When the area of the square is subtracted from the area of the rectangle, the result is 56. So area rectangle, subtract area square, is 56. So all we have to do is find an expression to represent the area of the rectangle, which would be x times 2x plus 1, your length times your width. And the area of the square would just be x times itself, or x squared, equals 56. So then you can simplify this equation and get x times 2x is going to be 2x squared, x times 1 is going to be x. I'm just distributing that x. Minus x squared equals 56. So if I put the x squareds together, I get 2x squared minus x squared is x squared plus x equals 56, which is x squared plus x minus 56 equals 0. Because when you're solving a quadratic, bring all terms to one side equals 0. And this one again is easily factored because it's an easy trinomial. And that would be two numbers that multiply to give you negative 56 and add to give you positive 1 would be plus 8 and minus 7, which gives you the two solutions of x is negative 8 or x is 7. And again, because x in this case refers to a length or width, negatives don't make sense. So x would have to be 7. And it would be centimeters. And the question is determine the width of the square and the rectangle, which is what we set x to be, so that's our answer. So there's some practice questions there for you to try, and the answers are at the end there. I do have a mistake here in this. I noticed that this was supposed to be positive odd integers. Anyway, the answers are at the end there, and if you want to see how those questions are done, you can look at the Schoology page for that. In the Schoology section under class notes, we have those filled in.